Good morning, ladies and gentlemen. Today, let's get started. Let's get talking. Mass is how much stuff is in something. Your mass does not change depending on where you are in the universe.
Oh.
So here, the moon doesn't matter. Your mass is the same. An object's inertia is determined by how much mass it has. How could you measure inertial mass?
Seems like we did that.
We did this, right, with the hacksaw out?
Yeah.
Okay. So that was one type of mass measurement. The force of gravity acts on masses. And we've seen this before.
Yeah.
Right? This should be, review for the most part. Okay, this is new. Sort of new. The net force is the vector sum of all the forces acting. So force net, and this is the same thing as writing force net. This just means sum.
Right.
Weight is the force of gravity pulling down. We've seen this before too, right?
Yeah, but there's a problem with that one of those words up there, isn't there?
Weight is the force of gravity pulling down. Down. What does down mean? I almost forgot what
I know. What does down mean?
What is down? Is down in Merced the same thing as down in Atwater? Down in LA? Down in Greece? Probably not, right?
Whoa.
So what is down? What do we talk about down? What do we mean when we say down? Well, the other day we talked about the center of mass of the Earth, right? And how all the forces are basically an average pointing towards the center of the Earth.
Yeah.
So when we say down, we really mean the center of the Earth.
So the down depends on where you are as a direction.
Down depends on where you are as a direction. When we talk about weight as the force of gravity pulling down, we're talking about it pulling towards the center of the Earth.
Yeah.
Okay. Moving on. A field, here's a field, is a region in space where measurable forces are exerted.
Oh.
Okay. A gravitational field, G, new term. A gravitational field G at the location of an object with mass M.
That's the little guy right here. This guy.
Causes a gravitational force of magnitude mg to be exerted on the object in the direction of the field.
And what direction is that?
This is being pulled towards the center of the Earth.
Yep.
The gravitational field at any point in space may be measured thus.
Yeah.
Yeah, so the gravitational field, G for gravitational field here, and we can measure it if we know the force of gravity and we know our mass.
You got a mass, you measure the force of gravity on it, do the division, boom, 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 and it doesn't matter where you are, on the Earth, outside the Earth, wherever you are.
Oh, okay. So here we have a whole bunch of different equations. We've got Newton's law of universal gravitation here. We solved for mass of the Earth yesterday, and Cavendish gave us this. This is Newton's second law.
Yep.
Right? And then this is what we just talked about, the gravitational field. And it looks like we have two different ways of getting there.
Yeah.
So what is the strength of Earth's gravitational field at R equals that? We can use this equation, yes?
Yeah.
Okay. Should I do this over here?
I think you should.
Okay. Let's go ahead and do this. Actually, ladies and gentlemen, pause the video. Do it yourself.
Take these numbers, plug it into that. You guys remember what G is, big G is. All right, go.
Okay. Now that you've done that, okay, let's go ahead and figure this out. This was 6.67 times 10 to the negative 11th.
Yep.
And then my Newton's kilograms squared over...
Wait a minute, it's meters squared over kilograms squared.
Huh. Mass on top, though, isn't it? Think about it.
Force.
No, it is. Right?
Yeah, meters squared over kilograms
Meters
squared.
squared on top. Newtons meters squared over a kilogram.
But you knew that, boys and girls. You saw we made that mistake right away.
Yeah.
Right? Yes.
Okay, oh, sorry. So that's this, okay? And then we want to multiply that times the mass of the Earth, which was 5.98 times 10 to the 24, big number, kilogram. 3.85 times 10 to the 8th meters. Okay, I think we're set to go, yes?
I think so.
All right, here we go. So, should I put this one in parentheses?
Nope.
Just go straight through
And
with the
just
numbers.
That times that divided by the other one.
6.67 times 10 to the negative 11th. Okay, times 5. What if you had to put the units in? Times 10 to the 24th divided by 3.85
Should get a number smaller than 9.8.
times 10 to the 8th. And we get, oh, I forgot to square it.
Oh!
Oh! Miss Mark!
What do you think you are, a student?
Okay, re-entry, and then we just square the bottom.
Yeah.
Aha! There we go. 0.0027.
0.0027.
Wow, that's pretty lame.
So what we've done is we're away from the surface of the Earth, and you get a fall off in the intensity of the Earth's gravitational field.
So I kind of jumped the gun on the units over here, but I canceled these and I canceled these, canceled that, and I canceled one of those, and we're left with Newton kilograms. Isn't that what we said? Gravity? Yeah, it's not gravity. The gravitational field equals the force of gravity over our mass.
The mass, yeah.
All right, next up. More equations.
Those looks like the same ones.
The
Different
same
arrangement.
side.
No, that is the same one.
Yeah. Okay, so we just used this guy right here to calculate the gravitational force.
The gravitational
Digital
field,
field.
which is also the acceleration due to gravity at that point. And that's way up of the surface of the Earth, and it's not going to be very much.
A field is a tool that allows us to visualize how forces are exerted in space.
The arrows are longer and closer, yeah, and smaller farther out.
Yeah, which makes sense. The further we go away, the less that force is, less strong. Okay. The gravitational mass of an object determines the amount of force exerted on the object by a gravitational field. And last but not least, near the surface of the Earth, our gravitational field is this. And as you can see, the further we got away over here, it got smaller.
Yep.
Right? Makes sense. Okay. That's all, folks. Oh, wait, one more thing. Your homework is going to be page 114, numbers 21, 22, and 23.
Go get them.
Get them.